Hi everyone, welcome back. Today we are going to build a map covering Manhattan within New York City. The topic of this map is dimensions, where instead of the usual perspective of visualizing buildings, namely putting them out in 3D, showing the building height distribution, now I will show you how the built-up area evolved in Manhattan over the course of more than 200 years. So here we will create an animated map where every frame, every snapshot will correspond to one single year, so as the years will go by, the more and more buildings will be added, showing how the whole peninsula of Manhattan became so densely built. So let's see how this works in Python. So here we are going to work with a map of New York City containing all the buildings of Manhattan. So first, we should go to the New York City Open Data portal and download this building dataset. This includes all the building footprints and a couple of other useful information, from which now we are going to use the year of construction of the buildings. So once we are here, we can look around. Here you can also see that this dataset contains more than 1 million buildings and altogether 16 columns, and here are all the different columns, their names, and very briefly their meanings. So let's download the dataset by clicking on the export button here, select the desired format, which I recommend to be GeoJSON, and then hit download. So there are 1 million building footprints here, so I would expect this to be a relatively large file. So let's give it a few minutes to finish the downloading process. Once the downloading is complete, let's move on to the Python terminal. Here I also added the link where you will find this dataset. Now, after the link, let's also do a few imports, or well, maybe even before that. We will import the usual stuff, pandas, geopandas, and matplotlib, tqdm to follow the progress of a longer for loop, which you will see very soon, and image.io, which we will use to create one single GIF from loads of frames. Let's see how we can build this map. First, we will need the admin boundaries of Manhattan, which you can also source, for example, from the Open Data portal or from OS7x as well. Let's see how that works. So this wasn't part of my script, but let's see how we can get the polygon of Manhattan real quick. Yep, so that's it. If you don't have the Manhattan polygon here, you can just create it and query it from OSM, just like that. Then run this cell, and remember here this will contain all the buildings of Manhattan, so make sure to overlay it with the admin boundaries of New York City. This way we will filter down the New York City-wide building dataset to Manhattan only. And then let's do some cleanup, drop all the things we don't need. Also make sure we only carry on the part of the data frame that we are going to be using later on. Yeah, I changed my mind in the middle, so I'm not using roof height here, so I will delete that as well. And turn the construction year column into an integer. And finally, let's see how many buildings we ended up having here. So the overlay may take for a few seconds, but in the meantime, let's create the output directory. That's going to be the frames folder, where we are going to save Manhattan level maps for each year based on the construction years of the buildings. So now let's design our core figure. For that, we will need to define a limit here parameter and split the building dataset into two parts, one before the limit here and one after it. Then we define the plot canvas and set its background to be black, and then plot the after layer, so the layer that hasn't been built yet, with pale opaque gray, and we plot the layer that has been built already in crimson. We also add a fairly large label positioned in the bottom right of the image, where we will show the year of this dataset with a relatively large, bold weighted font in white. Then let's switch the axis off, and from my notes I will also set up an X and a Y limb, and with that we are nearly done. We just need to set the layout and show the map. And now, since we switched the axis off, which we earlier colored black, we will have a white background, so let's just get rid of this line of code and see how it looks like. Okay, so now we have a nice dark and black map with all the buildings built until 1900 colored in red. Build a loop which will iterate over every single year from 1800 to 2025. This way, we will have one yearly snapshot of Manhattan every single year, so we will have more than 200 frames, each showing how the built-in area has increased from one year to another. So, in case an image, a frame is already out, then we will add discard just because I've already generated the images. But for now, let's just do a quick test. So we will run the for loop and these commands no matter what for every 100th image. And what we will do is that again we create the figure and color the axis black. Add the future layer and add the past layer in gray and crimson. Then we will add the text just as before. And now we are not removing the axis, so this way we will preserve the black coloring, we will set the limits, the title layout, and finally export the image and close it. Let's see how it runs. So there are no errors, it runs smoothly, and thanks to the tqdm command, we can actually track the progress of this for loop. So now let's delete this part and make sure we process every single frame, but I will also check if they exist. If they exist, then we don't do anything. And the reason this loop finished so quick is that I've already generated all the frames before. Now let's read in the frames and parse them with image.io, which is going to be a very simple way to join all these images, all these frames, into one single GIF file, which we are going to call time-lapse. So after the reading and the image processing and parsing is done, I will run this line of code, which will turn all these frames, all the 225 years, covering more than 2 centuries of buildings in Manhattan, into one single GIF file, which we finally will be able to open in whatever viewer we want, or even load it here thanks to the IPyDisplay package. So it may take a few seconds until image.io joins those more than 200 images, but once it's done, we will see in time, so in the temporal dimension, how Manhattan has built up over the past 2 centuries. So sit tight and enjoy the code. See, late 19th century, pretty slow, and then early 20th century, big boom. And then, since it seems to be starting to slow down, and by now probably every single available patch of land or free parcel was used, or for example preserved for green area. So this is how we can visualize time, the temporal dimension, and put it in a nice animated GIF format. So thanks for listening and see you next time.